And now we want to go a little bit deeper into 2 or 3 aspects of the data spaces approach of IDS. And therefore, I welcome warmly my colleague, Sebastian Steinbuss, who is the CTO of IDSA. And he will explain us how this, what Lars just explained, will be supported by different enabling technologies. Sebastian, welcome. And yeah, the floor is yours.
Thank you, Thorsten. Thanks to all of you for joining today. Yeah, and thanks for the good words of all the presenters before. Yes, I will go a little bit deeper into the technical details of the International Data Spaces Reference Architecture models and of the core technical concepts of the IDS. And I saw a few questions flowing through the chat window. I think I can pick up a few of your questions during my talk. So we already started there. So the IDSA, we defined a reference architecture. Of course, we also defined something like interfaces. We are working on a contractual framework, and we do also provide sample code. We are not an open source association, but at least we provide a sample code. But the most important thing is reference architecture. A reference architecture really as a blueprint to create data spaces and one data space, however you name it. And you saw this picture already in last presentation before. This is a data space, one data space. And you can see that this data space is bringing together different existing platforms. It's not the new platform, the next platform, the one to rule them all, but a system, a concept to bring those different systems together. To bring those different systems together, we defined a very generic scheme of the different roles inside the international data spaces and how to share data between different participants. Of course, we do see the data provider and the data consumer on the other side. So one that provides the data and the other one that consumes the data. So, and as you can clearly see, there is no man in the middle between the data provider and the data consumer. And we do see that the data provider provides the data of the so-called data owner. When you come from a legal perspective, there is nothing like data ownership. But I'm very sure that you clearly understand who is the owner of the data when we use this word. It's not so clear anymore to anyone when we talk about a data sovereign or something like this. And if there is only the connection between the data provider and the data consumer, you have to find each other. And therefore, we created the role of the so-called broker service provider, the metadata broker. The idea here is that you can register the data that you want to provide into the data space or into data spaces. That's this metadata broker. Publish your metadata. I do provide data of this kind. And a data consumer can search for this. To support really business and economics inside the data spaces, we provide the so-called clearinghouse. You can make use of an audit log here for clearing, for settling, or for going to court after a data transaction. And we also see the need for apps, for an app store or something like this, so that the data can really get put into usage, into use inside the trusted runtime environment, the so-called IDS connector. This is a very general idea of the IDS, of the data spaces. And you already saw this on last slides. So there are basically 3 different USPs that we do see and 3 different requirements that you need to create a data space. Of course, we need interoperability. Every system inside this data space has to be able to communicate with every other system. And in the first term, because we are talking about data sovereignty, you have to understand what is on the other side, who is on the other side. And so we focus here on interoperability on metadata level. And therefore, we created a metadata model, the IDS information model, an ontology that defines what kind of data do you offer, and with which service interface do you provide to consume the data or to use the data, and who do you are. What kind of company are you? What capabilities do you have to maintain my data? And of course, we do explain how data can be seen as an asset, as a commodity. I will come back to this in a few slides. And then the second important thing is to provide trust between those different security domains. And of course, here one of the most important aspects is certification. So we have to identify how trustworthy is the technology that is used. Does it follow best practice on secure software engineering or not? And how trustworthy is the operational environment, the participant in the IDS? And this is transparently visible to everyone. So you can see how trustworthy this one is. And you can decide, will I give my data to this party or not? And is he capable to take care of my data or not? This is the most important things really to establish trust between different security domains. And the third thing is to really create a comprehensive governance model in this data space. Of course, in the meaning of technical enforcement of usage policies, providing usage policies and enforcing them technically, but of course also to provide organizational measures and legal measures on top of this for things that cannot be enforced in technology. As already said, the IDS information model is provided as an ontology, so the leading model here is a declarative model, an RDF graph, and we do explain it, of course, on a conceptual level as a UML model. And you can see that we have 6 different concerns that we are covering. The easiest one is, of course, the communication part. So what kind of operations, what kind of endpoints, and what kind of messages are used to exchange data. Well, we do provide context, the context in where in space and time was the data created or can be used, what kind of content will be provided, what kind of resources, what kind of representations, is it a CSV file, is it XML, is it a JSON, and so on and so forth. And we can describe the concept in a very generic way. Here we can link the specific concept that is used to describe the payload data. The IDS information model does not describe the payload of the data, but the generic concept, and you can link your tangible concept, your asset administration shell, your HL7 data, whatever, to this IDS information model. And we see the so-called community of trust. Based on certification and based on the essential IDS services, you can identify who is the participant, if it is required to know who the participant is, or see, what capabilities does he have? How secure is the system? How secure is this environment? Am I willing to share my data with this one? And if, under which conditions? And then, this is really a new aspect, data is a commodity. What is the provenance of the data? Where did it came from? From which data sets was it derived? What kind of quality is related to this data? What policies, which usage policies are associated to this data sets? And of course, what is the pricing of this data? In general, as already said, the data exchange between 2 so-called IDS connectors, the connectors as trustworthy data runtimes, there is only the data exchange between 2 connectors. And the broker, the metadata broker, only knows about metadata. And you do not need the metadata broker at all to exchange data in a data space. You can also directly connect to each other if you know the other's endpoint. The good thing is everything that works between 2 connectors will work between every third connector in the same way because you're relying on a standard. And as the IDS connector is a trustworthy runtime, it is certified, certain security measures are on top of this. You may specify usage policy that your data may not leave this trustworthy runtime. So if the data may not leave this trustworthy runtime, but you want to make use of the data, you have to put the business logic inside your connector. And this is why we see something like an app store. You can put the business logic inside the connector and do the analytics. In the connector of the data consumer, and of course also in the connector of the data provider. Maybe your data is too large or too sensible to share it, then the data consumer could send his algorithm to the connector of the data provider and analyze the data there in situ. Because we do have to see that there are so many different kinds of data spaces, we have defined for now 4 different security profiles. Basically, it's 2 different security profiles, a base profile and a trust profile. The base profile, the general base profile, is an easy starting profile with not too many high requirements, easy to start, but not that trustworthy. So maybe you might think about sharing your important data with a base connector. But there are a lot of use cases where standardized data sharing is required and important. But trustworthiness is not required on a higher level. So a connector that fits the base requirements might be sufficient. For other scenarios, we need more security, more trustworthiness. And therefore, we have the trust profile. The trust profile is, of course, interoperable with the base connector and with the Trust Plus connector. But he definitely implements enhanced mechanisms for usage policy enforcement and higher security levels. This is important for more important data. And then we have this Trust Plus or Managed Trust Plus profile, where you don't have access to your connector at all because you're a service provider, and the connector that you're providing will not run inside your own environment, but maybe at your customer side. And then we have the so-called base-free profile, or something like a do-it-yourself profile. So you can implement whatever you like there, because this base-free connector will not be able to connect to a base, a trust, or a managed trust connector, as it will not be certified. But you can use the things that are important from your perspective, from your use case, from your data space, for your data space. Make use of the IDS concepts, but you don't have to be certified. But if you do so, if you implement the IDS concepts, it's an easy way to get a certification and then be part of the global data space. Coming back to the usage policies, sometimes access control that we're talking today about is not enough. You want to also manage the access to your data after it has left your own data center. I have here an example in an industrial data space. If you have a CAD data, configuration parameters, product volume, you may provide this data to another company, but only for a certain kind of machine. Or if you provide a CAD file, then you want to have it deleted after the first use, after it was printed in additive manufacturing or used in any other system. And of course, from the same machines, you may want to provide data for maintenance, for cooperative maintenance. But then you also want to provide the content. It's only for maintenance. It's only for maintenance of the machines and to provide predictive maintenance models, but maybe it's not for benchmarking, which the machine performs best. So we can provide this usage policies, and I will explain a little bit in detail how this works. What we can do today typically is access control, but we are not really able to express complex conditions, and there are only those binaries, yes or no decisions. I will give access to my data or will not give access to my data. Maybe we can work about the application context that a certain system or software may use the data, or if you have a certain role in the Active Directory, you may assess something. With attribute-based access control, we can do a lot of more things. For example, we can specify the security policies have to be up to date. And if you're working on a tablet, you will not get access because you might be in a train and not in your office, and so on and so forth. So you can really build complex things. But after you've given access to your data, you can do with the data whatever you want to do. We want to change this. We want to really enable usage policy enforcement, so that maybe the decision is not only giving access or not, but also, yes, give access, but only for 3 days. But yes, and if the data is used, inform the owner in a GDPR-related scenario, or is the same for no. No, you may not use the data, but we have to inform someone. For example, in a GDPR-related scenario or in other scenarios, and so on and so forth. And this is something that we do really need when we really want to bring together data from different companies and mix and reassemble data to create real cool, smart new value out of this. So what do we need for this, and what are we working on? The first very important thing is that we need a language for the specification of data sovereignty, of these usage policies. They have to be interoperable. They have to be understandable by a human and by a machine, and have to be interoperable, understandable. And the second thing is that we do need technology for the technical implementation of data sovereignty. And we want to push the limit here. We want to have as much technical enforcement as possible. But we are aware that we cannot enforce everything in technology. We can do a lot, and the more you want to do, the more expensive and the more complex it becomes. So, but we can do a lot, and there are technical frameworks also in place. But our main focus is still the language and the specification of different usage policies. And how does this fit to the whole concepts of data spaces and into general company strategy? So first of all, you as a company do need data. You need correct data. You need to know where does the data came from. You need to know about the pricing, about the usage policies of the data. So the generation and the processing of the data and the exchange through the internet is very, very important. And this is where the IDS really helps and supports you for your new use cases. And then we have technologies like 5G. We need interconnection. We need really availability and connectivity between different companies, between different countries to exchange data. And then we need this always available computing and storage system. We need cloud-based systems, for example. We need data steers where we can bring together different data sets and work on this. And if we do have all this data, then we can do cool new AI, like, for example, in platforms that are developed in AI for EU. So that was my part.
Thank you, Sebastian. Thank you very much for this really deep dive into some of the main IDS enabling technologies. Let me just briefly pull or pick 3 questions out of the chat, which might be of importance, 2 for Sebastian and 2 for Lars. So the GDPR issue was again asked in the chat. You mentioned it, Sebastian. So the relation between IDS and GDPR, is it possible to summarize in 1 question?
Yes, it is easily possible to summarize this. So IDS is a lot of technical measures that we do provide. And GDPR related issues are mostly organizational related. So IDS can support with technical measures to fulfill GDPR requirements. For example, by having encrypted transfer. Encrypted transfer is default in IDS, and this would be required. And that we do have this auditable logs and so on. So we have technical measures, but most GDPR things are organizational related. And there are other certificates, other projects that do support on those organizational issues.
Okay, perfect. Thank you. And the second question for you, I think it comes also from the health sector, data of individuals. How are data of individuals, for instance, patients, treated by the IDSA concept or approach?
So we do not really specify, as already said, what the payload of IDS is. But we can do several things. For example, we can specify usage policies. And this is another usage policy use case that I omit in my slides. For example, when you make analytics on patient records, that they have to be pseudonymized or anonymized, and we can specify this, that they have to be done so when leaving the connector or when entering another connector, that you do have to do a certain processing, then afterwards it will be anonymized. So these are things that we can really do and support. And there are concepts people are working on in one of our communities, the so-called medical data space, where there is detailed work on medical data and on patients' data.
Okay, thank you for this short answer. Then I want to pick 1 question, which I want to ask Lars. When we, well, there's 1 question which relates to IDS as a cooking book. And the question is it just to engage with IDS? Maybe you could also explain who will use IDS technologies or IDS concepts. Maybe this is a question for you.
Yeah, thanks a lot. I also saw this question, so thanks a lot. Well, definitely, yes, we want to provide a cookbook, but we are not the cooks and we do not run a restaurant. So the IDS reference architecture is a reference architecture which is in the first technology agnostic. In the IDS association, which is a not-for-profit association, everyone is free to join, and we have a lot of companies there which are building solutions upon this reference architecture and bringing this into concrete solutions, be it services, platforms, whatever. So this is currently going on, and we have an activity which is called the Launching Coalition. So there will be companies out there which will provide services or components, for example, the connector with IDS inside, and this is then certified by third parties that this is done according to the reference architecture. And I read also this question. So who takes over the certification? Well, this is again open to companies out there who are used to do it. For example, PricewaterhouseCoopers or TÜV organizations in Germany, and all these testing and evaluation facilities all over, so in every country, they are free to certify these components as long as they are approved by IDSA, stating that they follow the rules of procedure and the value proposition which I mentioned, and there will be a lot of evaluation facilities, and probably in each country it will be different.
Okay, perfect. And then the last question with a very short answer, please. How is the relation between IDS and Gaia-X?
Yeah, I also read that. So I once referred to it. I have this architecture stack for digital ecosystems, and there's this data infrastructure layer, and these are the data spaces, and Gaia-X is beneath. So talking about the cloud and edge devices and the nodes where the data is stored. So it's a little bit like Gaia-X is focusing on data in rest, while IDS is focusing on data in motion, so talking about usage of data and all of this, while data is shared. And when you want to talk about, okay, where to store data, so following European law and European values, and you don't want to have it on one US or Chinese cloud, then this is the issue of Gaia. So when talking about digital sovereignty, it's about data sovereignty and cloud sovereignty. And if you merge this, this is merging IDS and Gaia, and we are in a very close relationship. And this is probably a very good idea when it comes to a really comprehensive view on digital sovereignty.
Perfect. Thank you very much, Lars.